All right, today for Algebra 1, we've got section 1.6, we're dividing rational numbers. So our objectives today are to divide assigned integers and rational numbers, demonstrate that division by zero, okay, so dividing by zero is undefined, and we're going to identify and apply the properties of real numbers. Okay, so vocabulary to think about. Okay, is when we have this dividend divided by the divisor equals the quotient. Quotient is probably the word you're the most familiar with. The first number is always called your dividend. Okay, you're going to divide it into parts. So if we have 24 divided by 6, that equals 4. The dividend is the 24. I always think about it as like opposite. It's dividend, but it's actually the first number in a division problem. That helps me think about it. So the dividend is the first number, and then the divisor is the number we're dividing it by, or how many groups we're trying to put it in, and the quotient is our answer to the division problem. Okay, we talked about these symbols a little bit to help you remember about multiplying and dividing positive and negative integers. So if factors are both positive or both negative, the product is positive. Okay, so if I have a positive times a positive, my answer is positive. Or if I have a negative times or divided by a negative, my answer is positive. Okay, so the same sign, okay, if they're the same sign, it's going to be positive. The other one is if the factors are, if one factor is positive and one factor is negative, the product is negative. So this applies also if a dividend and a divisor. So if we have a negative number divided by a positive number, our answer is going to be negative, right? It's a sad little negative. If we have a positive 24 divided by a negative 6, our answer is going to be a negative 4. Okay, so if they have different signs, okay, then we're going to have a negative answer. So hopefully that little shortcut continues to help you with that. So let's look at some examples, because that's the only thing about division, right? Is thinking about the signs. So 14 divided by 2, this is a positive, this is a positive, so my answer, because they're the same sign, is going to be positive. 14 divided by 2 then is just a positive 7. I have negative 72 divided by 9. I have a negative divided by a positive. I have different signs, so my answer is going to be negative. So it's going to be a negative. 72 divided by 9 is 8. So negative 8 is our answer. 105 divided by negative 21. Okay, so again, we're just looking at those signs. 105 is positive, divided by a negative 21. So that's a negative. So because we have different signs, our answer is going to be negative. So this is a negative 5. Right, because we've got that negative and a positive. D, we have negative 864 divided by negative 36. Those are the same sign, so we get a positive answer. So 864 divided by 36 is a positive 24. All right. We also then have the reciprocal or the multiplicative inverse. It's two numbers whose product is 1. So in symbols, we would say A times 1 over A. Because this A, right, we could also say this is A over 1 times 1 over A equals 1. Or you can change the order. 1 over A times A, or A over 1 equals 1. Okay, so these reciprocals. So the reciprocal of 2/3 is 3 over 2, because 2/3 times 3 over 2 equals 1. So think about it like regular multiplication. 2 times 3 is 6. 3 times 2 for the denominator is 6. So 6 over 6 is equal to 1. Okay, notice here, negative 5 and negative 1/5 are reciprocals. They're both negatives, so it's not the same thing as opposites. They're reciprocals. Because we have negative 5, if you want to make it to a fraction, would be negative 5 over 1 times negative 1/5. Okay, we have a negative times a negative, so we'd have a positive answer. 5 times 1 is 5. 1 times 5 is 5. 5/5 is equal to 1. So those are our reciprocals, or the multiplicative inverse. The other thing that we have, 18 divided by 0 is undefined. Okay, so that's just one example. any number divided by 0 is undefined. It's not possible. It's like if you're taking, because what division is, remember hopefully from younger years, is division is like dividing things into groups. If you have $18, can you divide that into 0 groups? No, that's impossible. You're always going to have at least one group of 18. You cannot make it into 0 groups. That is impossible, or we say undefined. Okay. Division. Okay. Division can be defined as multiplication by the reciprocal of the divisor. So we have this a divided by b, which can be written as a fraction, right? Division is or can be written as a fraction. But we could also say, oh, that's the same thing as just saying a times 1 over b. And if we look at it like that, or even like this, we have to recognize that b cannot be 0. So this number right here cannot equal 0. Our divisor cannot equal 0 for us to actually get an answer. All right, so let's do some examples there. Oh, sorry, my board's not clearing out there. There we go. Okay, so let's look at these examples and maybe use some of those properties to help us. Okay, so example 2, A, we've got 4/5 divided by 9/10. Okay, so how could those principles help us a little bit? Maybe that multiplicative inverse or the reciprocal that we just talked about. How might that help us? Or looking at it as undefined. Would either of those things help us to solve this problem? Okay, let me go back a little bit. Let's see if I can get that in there. Oh, sorry, I was thinking it was on the multiplicative inverse part, but it's not. So in this division part, we said it can be defined as multiplication by the reciprocal of the divisor. So, okay, we've got this a divided by b, which is the same thing as a over b. But then we said, hey, we could multiply these instead. Well, and that's kind of hard to see, but we can do that here. We can multiply by the reciprocal of the divisor. So we're going to take this, okay, and we're going to change it. We could say, oh, this is the same thing as 4/5. We keep that, and we multiply by the reciprocal of this divisor. So we're going to multiply by 10 over 9. Okay, to make that a little bit easier. Then, if you know you can cancel like things, right? I would cancel this 5 and this 10. 5 goes into 5 one time. 5 goes into 10 two times. So now I would have 4 times 2 is 8, and 1 times 9 equals 9. So this is 8/9. We can multiply by the reciprocal. Maybe you need to write yourself a note there. Multiply by reciprocal. This is so much easier than trying to divide it out. Okay, so if we look at B, we've got -5/7 divided by -5. Again, so we can think about this as a fraction, so it makes it easier to change it to the reciprocal. And then we're going to multiply by the reciprocal. So we're going to have -5/7 times the reciprocal, -1/5. Okay, first of all, then a negative times a negative is going to give me a positive answer. Awesome. I have a 5 in my numerator here and a 5 in my numerator there, so those cancel to be 1 each. So 1 times 1 equals 1, because I know my answer is positive. 7 times 1 equals 7. So my answer is just a positive 1/7. All right, C is going to be a little bit more work because we have mixed numbers. Okay, so we've got to make our mixed numbers into improper fractions before we can divide. Okay, so 1 and 7/12. Remember, this is 12 times 1 is 12, plus 7 is 19. So it's going to be negative 19 twelfths divided by, here we have 7 and 3/5. So 5 times 7 is 35, plus 3 is 38 fifths. All right, then we're going to multiply by the reciprocal. Another way you might have heard this is keep, change, flip. Have you heard that? Or KCF? Because we keep our first number, the dividend. We change the operation from division to multiplication. So let me rewrite this. We're going to keep this one. We change the operation from division to multiplication, and then we flip the divisor into the reciprocal. So if you've heard keep, change, flip, that's the same thing as multiplying by the reciprocal. Okay, it's just a shorter way for you to remember it. All right, so then if there's anything that cancels there, right, you can do some cross canceling. So I know that 19 will go into 38. So I'm going to cancel my 19. 19 divided by 19 is 1. 38 divided by 19 is 2. I have a negative times a positive. So that's going to give me a negative answer. So this is going to equal negative. 1 times 5 is 5. 12 times 2 is 24. Negative 5/24. And because I canceled here, right, I keep my numbers small, and they should be simplified already by the time I get to that last step, as long as I've canceled with the biggest number possible. All right, great. Then we're going to look at some complex fractions. Okay, a complex fraction is a fraction whose numerator and denominator contain fractions. So here's the deal. Like, this is our fraction bar. We have a fraction in the numerator, 1/2, divided by a fraction in the denominator, 3/4. But again, fractions are division. So all we have to do is say, oh, this is the same thing as 1/2 divided by the 3/4. And then once we know that, we can just multiply by the reciprocal, or we can do the keep, change, flip. Okay, this is a simple one if you don't want to cancel, right? You could do 1 times 4 is 4, 2 times 3 is 6, and then you have to take that next step for that they're both divisible by 2. So 4 divided by 2 is 2, 6 divided by 2 is 3. Okay, or you could have canceled here. 2 divided by 2 is 1, 4 divided by 2 is 2. 1 times 2 is 2, 1 times 3 is 3, and get 2/3. Either way is perfectly fine. All right, so let's change this complex fraction into a division problem. So this is going to be what? Excellent. We're going to have 4/5 divided by, nice, negative 1/2. Perfect. Then in order to solve it, what are we going to do? Good. We're going to have 4/5 times negative 2/1. Perfect. Does anything cancel there? No. So 4 times negative 2 is, awesome, negative 8. And 5 times 1 is, perfect, 5. And you can leave it just like that. Remember, I told you you're welcome to leave it as an improper fraction as long as it can't be reduced any further. And 8 and 5 don't have any common factors. You do not have to make it a mixed number. Ooh, how about B? How about B? How will we change that to a division problem? Good. Okay, so this is our main fraction bar. So this is 2/3 divided by 4. Okay, that's great. Now let's take that and make it into a fraction, right? 4/1. What's the next step? Good, multiply by the reciprocal, or keep, change, flip. So we're going to have 2/3 times 1/4. Anything cancel? Absolutely right. The 2 and the 4 do. 2 will go into both of those numbers. 2 divided by 2 is 1. 4 divided by 2 is 2. So 1 times 1 equals 1. 3 times 2 equals 6. Perfect. So 1/6. All right, example 4 is our last one there. We want to divide 1.26 by 0.3. All right, and we've got this nice little note over here that says, don't forget to move the decimal. Don't forget to move that decimal. All right, so hopefully you remember that the first number, right, that when we say divide 1.26 by something, our dividend goes in the box and our divisor comes outside. Okay, when it says don't forget to move the decimal, it's talking about the decimal out here, right? We want to make this a whole number. So we move that decimal over until it makes a whole number. So in this case, it's just 1 time. So we have to do the same thing in here. So now we're really looking at 12.6 divided by 3. Okay, I'm lazy and like to save space. I would never rewrite this, but that's what we're really doing. So 3 does not go into 1. 3 goes into 12 4 times. So we're going to subtract 12. We have 0. Since our decimal was moved to here, we have to move it up. And we bring down our 6. 3 goes into 6 2 times. So we subtract 6 and we have nothing left over. So our answer is 4.2. And it is positive because we had a positive 1.26 divided by a positive 0.3. So our answer is positive. Okay. So that is it for today. Just again, we're dividing those integers. There are those properties down there to help you remember all the different properties that you can use of addition and multiplication, and you know them. Okay, you already know those things, but sometimes we forget them or we don't know the name of them. So they're just there to continue to be reference for you. All right, have a great day and we'll see you later.